you need to, this is a typical rating that you will find out. When you multiple it with the 10 or 100 or 1000, no, this is what the maximum rating you will be getting, guys. Okay, so this is how you'll get it. So generally in this order you can go with, that's the number it says. When you look at this R10 series, no, the number series based on that, like you need to multiply it. So you see that in that way up to this you will get that. So normal you will see. Beyond this, maybe it will be a medium voltage transformer or something like you can call it. But yeah, rating will be high, right? So this is that this snap I have taken it from that standard only. Okay, just for your information, this one only, right? Right. Second, there are other modes like cooling modes, loading beyond rated power. There are certain things that you need to look at. Okay, so you see that load rejection on transformer directly connected to the generator, right? So when the load rejection happens, no, it shall be able to withstand 1.4 times of the rated voltage or 5 seconds, right? To which the generator, these are the conditions that you have to meet. It is very important, right? So that is one thing. Then cooling mode. We'll talk about cooling mode. There are two things. One is air or water, right? That we'll talk about that. Then loading beyond rated power. This you don't need to worry about that actually. Generally, we don't do it, and we'll never allow transformer go beyond rated power actually. Okay, but what happens when there is a loading of the transformer goes beyond nameplate rating, right? So there is a some criteria that it may withstand, but you cannot do for entire type. Continuously you cannot do that. That's what it says. That is one thing. Then the minimum power under alternative, cooling modes, right? We'll talk about that. So these are the important factors that you need to think. Then rated voltage, frequency. Frequency is nothing that one thing. Mm, winding connection we talked about, star and delta. That is one thing. Transport thing that you need to look at. Then yeah, the tapping part we are mentioning it, no, the tap range that you need to specify it typically. Okay, so that is also very important. See why we are talking about tapping is very important. See, this is HV side and this is LV side. Let's say that this is 11 kV actually for the discussion part. So you see that when you get the power from EB, you may not always get exactly 11 kV. Do you all agree with me? Right? So sometimes it will be 10 kV. Sometimes it will be 11.5 kV. Right? So there will be a percentage of, the tolerance. Right? Generally, this one we call it as a plus or minus 5%. Okay? Even sometimes it may go beyond minus 10% also. Right? Typically, when you look at our Indian EVs, no, still it may go little less only, right? That means there will be a huge voltage drop might be there. So in that case, you imagine that. See, when the load, when the voltage is less this side, what happens on the this side? So let's just a thought. You just put it, no. So for that, that's what you need to look at, guys. So you can also talk in this way. So let's take one case. So you see, this is how you can, when you are using ETAP, you have to model it like that. This is how you have to model as well. So take transformer, you give the transformer name and etc. So generally transformer connections will be three phase or single phase. So three phase only we are dealing with. So when you want to mention, right, right, that is one more single phase connections also will come. Just give me a moment. That is why it is not coming. So single phase connection also you can do it. Okay, so no problem, that will do it, we deal it later little. So that will come. Then you have to specify, let's say that 10 will give it. So 10 we will give it, that is 10 MVA. Then your primary side will keep it like 33. Your secondary side will keep it like 11 kV, just for the discussion. You see, this is the current that you are getting it. See, when the 33 kV becomes 32, right? When the 33 kV becomes 32, or when the 33 kV becomes 34 kV, something like this is quite normal. See, when you have such a scenario, such a scenario, what will happen? That's what this tab changing talks about, right? So you see, there will be a one more point will be there. Okay, so the tab changer, from here you have to tap it like that. That means no matter what happens, the variation on the HV side, on the LV side, you should have the stable voltage, right? That's what the goal here. So that's why they are using the tap changer. That is very important, right? Which you need to specify it in the single line diagram after the calculation and etc. That you need to specify it. Okay. So if on load means what is the percentage? What is the steps that you need to specify it? If it is on load means what is the this thing? For that, how you have to find out is you need to ask your customer or something as an input. What is your minimum grid voltage? What is your maximum grid voltage? You ask this information from your customer, so he knows, right? So maybe he may say that generally if it is a 33 kV, so like I see that this is the my, he may say that. So like sometimes if it is a 33 kV is the nominal voltage, then he may see that this could be is maximum voltage. So he will say it like that. At the time, then you need to calculate that tap range and etc. Right. So that is one part, right? So now we'll specify here. You see that in ETAP it shows that all the full load current and etc. very easily. Then there are other steps what you have to look at here: altitude and ambient temperature, because when the transformer altitude changes, that means generally up to 1000 meter altitude, means from the sea level to like highest point, that the sea level is the base that we are taking out, right? So up to 1000 meter there won't be any deration. When you go beyond maybe 1500, you see that your transformer will be derated, right? Maybe 1100 onwards, you see, right? Your transformer is derated by 2%. So though like even though you are buying 10 MVA transformer, and if you keep it at 11,100 elevation, no, where you install it, no, your actual transformer rating will be 9.8 only. It is again like a cable deration we talked about, no, in the same manner it happens, right? This is one case. So like every maybe every, you see that every 100 it is getting derated. Can you see that? Every 100 like it is getting derated, right? So that means ideally your transformer will be getting derated like that. So you have to be careful depending upon the project site and etc. that you have to specify it. Okay, in your, even if in your single line diagram you have to specify those data, or while preparing transformer data sheet you have to specify those very clearly, so that only the manufacturer will consider those facts. Okay, so that is very important. Second, this is one page. Yeah, when you increase the ambient temperature, you see that when you like maybe this one will make it 1000. See here, see here, ideally it is 30, but just to please do not take this ETAP value, it may be wrong actually. So what I am trying to say is that when your transformer, see here ETAP 30 degree as a base temperature it is taking. So beyond when you keep doing it, no, when you keep increasing it, that will actually keep derating it. Every 1% of increase it. Do not take the, in a reality it may not be like that. Okay, so don't take this value, these two values. It is just available. That's all. Okay, just to understand it is there. That's it. Now, when you let's say that when your site rating is 45 degree, okay, then when you mention in your data sheet 45 degree, your manufacturer will give the transformer rating suitable for 45 rating and whatever that rating you have asked. That means 10 MVA. That will be there. So, but the same data while entering in the ETAP, don't put this 40 MVA. That will be the wrong answer. You have to keep as it is only. Do not change that while using the software, because the software is just a mathematical stuff. So in a reality, it won't be like that, right? So you should not use it. But ideally, the manufacturer will give transformer suitable for 45 degree Celsius, which means again that will be a 10 MVA only. So that means you, for your calculation, you have to use only 10 MVA only. Okay. So this while entering this value, do not do anything. Just leave as it is. Simply ignore it. Right. So that's one thing. So that is very important, because when you are using the software, you should understand that. Otherwise, it won't be useful. Right. So those information you have to be very careful, guys. Right. Second, when we mention it, that few things that we talked about, no. So here impedance, you need to mention impedance. Generally, uh, in the transformer, while specifying the transformer, by default, like you have to specify some information.